Today's discussion is about the scope of variables. What do we mean by the scope of variables? Well, a variable scope in C# and actually in any language determines where and for how long a variable is accessible. What modules or parts of a class or parts of a program can access the data in that variable, and what's its lifetime? How long is it hanging around? We're going to talk briefly about three kinds of scope. Class level scope, which exists throughout the class. Module level scope, which exists only within a particular module and isn't visible outside of the module. And then we're going to talk about block level scope, which only exists within a block of code. We'll see how that works. But we're actually going to start in the middle, in the mid-range, with module level scope. Module level scope is a variable that is created within a module. In this example, in button click, we're declaring a variable called Apple. We're setting its value to 2. It's visible only inside the module. Other modules can't access it, and we do not retain values between calls of the method. Every time we come into this method, every time that button is clicked, we set that value all over again. Let's take a look at how that looks in functioning code. So here we have button 1 click. We're initializing Apple, creating a new variable, parsing the data out of a text box. We're creating a second variable called orange. And then here we're adding the value of orange to the value of Apple. Now what's happening here, the value of Apple and orange will go away. The variables go away when the method is changed. If we had a second method, for example, button 2 click, and we tried to access either Apple or orange, that's not going to work. You're going to see that we get the name Apple does not exist in the current context. Neither does orange. Again, that's because these are module level scope. If we wanted things to go beyond one module, we would declare these variables at the class level. So rather than saying int Apple here and int orange here, we would take something like int orange and declare it up here at the top of the class. Now, as you can see, it's in the class, but it's not within any of the modules. So basically, it's visible from this opening curly brace, which is the first curly brace in front of it, down to when that curly brace is closed at the end of the class. So at this point, we're declaring orange here. It is a class level variable. It's set to 0, and we'll see that every time we push this button, we're going to get a new value for Apple, we're going to add that value to orange, and we're going to get a total. And we can do something like this. Let's add a label to display that answer. And we're going to call it, we're going to take the text out. We're going to change the name here. Label sum. And in our button here, we are going to say that label sum.text equals orange dot toString. Now, when we run this program, because orange is a class level variable, the value in orange will be retained every time we call it because this whole method is inside this class. Let's see how that works. So we run the program, we put a value in here, and we put 5 in there, push button 1, we get an answer 5. We hit it again, we get 10, we put 67 in here, we get a total. As you can see, every time we change it, and click this button, we're adding the new sum. So that's the difference between class level variables and module level variables. We'll also see that not only is orange available here, it's available here in this other routine. So we could, for example, if we wanted to say button to dot text, actually let's do something else. Let's set orange back equal to 0, and again we're going to copy orange into here. So when we run this time, every time we put a value in here, we click this, we're adding up. When we push bottom button 2, we're going to clear the value, and you'll see that this counting starts all over again. So that's the difference between module and class. Now, if we want to take a look at something that's within a block, we could do something like this. We could say, let's do this. If orange greater than 10, it's a simple if statement. We're opening up a new block. We can declare a variable in here, apple equals 0. Now this works. The reason for that is that this apple being declared in this method is separate from this apple declared in this other method. Both are method variables. What we can't do, though, is we can't say apple equals orange because this apple does not exist in the current context. Because it was declared within this particular block, it lives only within that block. So even though we're in the same method, since we're not in the same block as it was declared, this is not going to work. If we wanted this to work, we could say apple equals 0 in here if apple was defined as a class level variable, sorry, as a module level variable here. Now, we also have to be very careful. If we were to do something like this, int orange equals 25, that's perfectly acceptable. But here's the little problem. This int orange is a module, module variable. It hides this class level variable. So we could do that. It is legal, but we really don't want to do it because it's generally not going to give us the results that we want. So that's the quick summary, and we'll talk more about this as time goes on.